All right, so I didn't know if I'd have time to do as many example problems in class as I wanted to, so I'm doing a couple videos. Sorry that they're not cool Whiteboard videos, but it's a little bit easier to import an image on this platform. Okay, so the example I'm going to look at right now is we have this crank, and you can see right here that it's rotating with this angular velocity right here. And so that's the angular velocity of the piece that goes from O to B. And as that does that, of course, point A is going to move, and then what's going to happen is B is going to move upward. And finding that velocity of B is our end goal, but what we're going to do is we're using this relationship where if you know a velocity of a point on the rigid body, then you can find a velocity of a point on that, another point on the rigid body. If you know some things, if you know the position of the point relative to your reference point, and also if you know the angular speed, the angular velocity of the piece. So what we're doing here is we're going to say that because of the fact that we know that the velocity of A, because of the fact that we know how fast that piece is rotating, so that's going to be our reference point. Now, if we think about this rotation, this counterclockwise rotation, at the location that we're looking at, this is going to be the velocity of A. It's going to be in the negative x direction. So the velocity of A is going to be minus the omega times the r, which is minus the 12 radians per second times the radius, which is 0.3. So the velocity of point A is minus 3.6 meters per second. So we know that. And so the idea is, now that we know the velocity of A, we want to find the velocity of B. We'll be able to write the position of B relative to A, and we're going to, you'll see that we'll be able to actually figure out what the angular rotation rate of this AB piece is. Now if we think about it, as A moves to the left and B is moving up, this whole thing is going to be rotating like this. But you know what? If you aren't really sure, it's okay, because if you guess the wrong direction, your answer will just come up negative, and it's okay, and then you'll know that it's in the different direction. Okay, so that's the pieces of information that we have. Another picture. So I'm just going to rewrite a couple things. So VB looks like this. This is what we're trying to find. We're going to say that this piece is rotating in this counterclockwise direction, and we know that VA is equal to minus 3.6I. Now the equation that we're going to use is the velocity of B is equal to the velocity of A plus omega AB crossed with the position of B relative to A. And so really we want to just fill those things in. The velocity of B is equal to the velocity of A. So we'll start with that. It's minus 3.6I. Now for omega, if I say that this is my I hat direction and this is my J hat direction, and remembering that the direction of omega is along the axis of rotation, I know that the axis of rotation would be in the Z direction, and this actually would be positive Z, and so this can be written as omega AB times K hat. Now, what is the position of B relative to A? Well, I know that the angle that AB makes with the horizontal is 30 degrees, and the length of AB is 0.6. The x component is going to be 0.6 times cosine of 30. So that's the x component of the position of B. It's minus 0.6 times the sine of 30 in the J direction. Now I have to do some cross products. Now, the first thing I'm doing is K cross I, and I'm going to use this little device. This always helps me figure out what the cross products are. And remember, if we go around clockwise, to find the cross product. It's the next unit vector that you would come around clockwise, and it would be positive. So k cross I works out nicely. That just ends up to be j, so I have omega AB times 0.6 cosine of 30, and that's in the j hat direction. Now, the second one is k cross j. Notice I'd have to go counterclockwise to do k cross j. So it's still going to be the next unit vector that I get to, which is I, but it's negative I. Turns out, though, that I have a negative sign here, so I'm going to get two negative signs. So it's actually going to be a plus I. So I have omega AB times 0.6 times the sine of 30 times I hat. Again, I found out that k cross j was minus I, but I had this minus sign as well, so the two negative signs gave me a positive sign. All right, so I have this as the velocity of B, and you can see that according to this expression, I have two components, and I also have this unknown omega AB. But look at the structure and notice that B can only move in the vertical direction. So VBX is 0, and we're going to use that as a condition to solve for omega AB. So I'd have minus 3.6 plus omega AB times 0.6 times the sine of 30. So what I did was I collected all my I hat components, and I'm going to set them equal to 0. This will allow me to solve for the angular velocity AB. It's going to be 3.6 over 0.6 sine of 30. And I end up getting 4, oops, sorry, that was a different problem. I was remembering the answer to another problem. It's actually 12 radians per second. So that's how I find the omega. Then VB, which was in the j direction, I had was equal to omega AB times the cosine of 30 times 0.6. And if I put in the omega AB into this and crank everything else out, and this is in the j hat direction, right? So what I did here was I just took this and I put it over here. If I do substitute in my value for omega and multiply everything together, I find that the velocity of B ends up to be 6.24, and that's in meters per second, and that's in the j hat direction. So I think these problems are kind of fun. I don't know why, but you know, you can kind of go through, and sometimes, like in this particular problem, we were able to use sort of our observations, which in this case, for instance, was that the velocity of B could only be in the y direction. Actually gives us a condition that we didn't know we had at first. This gave me the condition that the velocity of B, the x component of it, had to be 0, and that allowed me to find my omega, which I then was able to use from in my expression to figure out what that velocity was. So just one more example of how we can solve these problems.